So, welcome to the AI Agent Moral Meetup. Today we have the amazing opportunity to have Adam with us. Little reminder about the meetup. It's a meetup for people curious about AI, and we want to demystify, but also spread and share best practices around it. And today we will see agentic AI coding and best practice patterns for speed but with quality. And about the organization, the talk is recorded and I will share it on our YouTube channel. Feel free to ask your question on the chat and we'll try to answer it along the presentation or at the end, depending on you, Adam. Just tell me. And because we have many attendees today, I think I will unmute all attendees. But anyway, we can ask your question on the chat, and I will try to answer it. So I will unmute, désactiver tous les sons. I will unmute you, Adam. Okay, so we can talk, Adam.
Yeah.
Okay. So thanks to be with us, Adam, and the place is yours.
Oh, thank you very much. So, hello everyone. Really, really good to meet you. So, I'm Adam Tornhill. I'm calling in from Sweden. So, I'm like 5 hours ahead of you. It's been a good day, so you have that in front of you. And now, anyway, I'm going to start sharing my screen and presenting soon. And I plan to talk for like roughly 30 minutes. I've never done this talk before, so it's pretty hard to know. But I'm aiming for 30 minutes. And then I like to take questions and have conversations around the topic because it's really, really exciting what's happening right now. And I'm super happy to share what I know, but of course also to learn from you. So if it's okay with you, I would prefer to keep the questions towards the end. Otherwise, it might be really, really hard to stick in the flow, but I'll do my best.
Okay. So we'll answer it at the end, right? Oh.
Yeah, but please feel free, of course, to post anything in the chat or whatever.
Okay. And maybe at the end, we'll try to unmute
Yeah.
posts.
That's always good.
Okay, and perfect if it is the first time for you.
So let's see here. So let me share my screen. That's the first thing. And then here we go. So now you should see my slide deck.
Yeah. Agentic AI coding patterns for speed with quality. It's perfect.
Yes.
We can start, yeah.
Perfect. And just a note that when I'm present, I cannot see you. So I would need one more screen for that. So I cannot see you. So if you really, really need my attention, then you have to call out during the presentation.
Okay.
But anyway, let's get started. Agentic AI coding patterns. So these are some patterns that I assembled that worked for me and my team and that we have successfully used with some of our clients over the past few months. And I would like to share them with you. But before I do that, I wanted to kind of share where I come from. What has my software developer journey been? How did I arrive at AI and agentic coding? So I have to tell you, I've been really, really fortunate that I started to code at a very young age. No, not really. This is not me, unfortunately. This is my son who managed to grab one of my Common Lisp books. But I was quite impressed because, just seconds after I took this photo, he started to tear out pages of that book, to keep as a reference for sure. So I'm a really, really proud dad. My own journey was a bit more traditional for someone from my generation. I started to code on one of these machines in 1987, so it's been almost 40 years. And the Commodore 64 was a really interesting start for me because it made me into one of these basic programmers, right? So I started out as a basic programmer. And that makes me into one of these programmers that Dijkstra infamously called are mentally mutilated beyond hope of regeneration. So that was my start to programming. I learned BASIC. However, to my credit, I quickly moved on and, started with other languages, did a lot of assembly programming, machine code, C, C++, so on. And the first real change for me in how I view programming came in the early 2000s. And it came through an article called Beating the Averages. So some of you might be familiar with this. If you haven't read it, I highly recommend it. It's an old piece now, but it's still, I think, very relevant in the AI age too. So Beating the Averages was an essay about how Paul Graham, and with his startup ViaWeb, used Common Lisp or programming language as a secret technology, right? Like a secret weapon to outperform their competitors. And the reason I kind of bring this up is because to me, agentic AI doing that well is also a secret weapon that will allow you to outcode your competitors. So anyway, this idea of using technology as a secret weapon really, really struck with me. And after reading that essay, I decided to learn Common Lisp and Lisp, various Lisp dialects in general. So I spent quite some time on that. I even wrote a book about it called Lisp for the Web. And I've been pretty much spending maybe 80% of my professional programming years since then in various Lisp dialects like Clojure and Common Lisp, most of it Clojure these days. Another thing that I think kind of changed my career a lot was that I wrote a book more than 10 years ago called Your Code is a Crime Scene. And Your Code is a Crime Scene is very much a book about how do you succeed with software development at scale. How do we ensure that we build sustainable and maintainable code that we can evolve as business needs change? And after writing that book, I founded my own company called CodeScene. And CodeScene is a company that simply automates these analysis techniques and do tools. And I'm going to give you a couple of references at the end. And yeah, I've been coding ever since, but I noticed that something has changed. Because for the past 5 to 6 months now, I haven't written any code at all manually, but I've been writing more code than ever before. And that's, of course, because I'm fully agentic now, right? So this shift to agentic AI came much faster than I expected. And after doing 100% agentic coding over the past 5 to 6 months, I kind of found that agentic coding is very, very similar to how I typically approach software development. It doesn't feel as different as I would have expected myself. However, I also find that agentic coding is harder than writing code manually, much harder. It's not easier. And that, of course, brings the question, if agentic coding is, if it's so hard to succeed with AI, why bother at all? What's like the return on investment? Why do we adopt these tools? And I think it's still too early to kind of, talk about general numbers from the industry. I don't think we are there yet. It's still early days. But I do happen to have data from my own team. So in my own team, every one of us only codes with AI agents. And what we measure is a 2 to 3x speed up on our tasks. So that's quite significant. And we are a small company with a small team. So being able to do things 2 times or even 3 times as fast is, of course, important to us. It's a very real and very tangible benefit. However, what I also want to point out is that focusing on speed alone misses the real benefits. Because the real benefit to me, the real value, lies in what speed enables. Because speed encourages experimentation and rapid iterations. So what this means is that I can do things I could never afford to do before. So for example, I often find that I do multiple implementations, to solve a problem. I can compare them. I can quickly change my mind and decide, hey, don't do it like this. Try, a data-driven table-based design instead. And then within 30 seconds, I have a new design and I can inspect it. And if I'm happy, I can just continue to iterate. So that's one clear advantage, this rapid iteration and prototyping that AI enables, which I think allows us to find a better overall design and architecture. Another big benefit I've learned with agentic AI is that agentic AI tends to remove coordination bottlenecks. So as concrete examples, I've never been particularly good at infrastructure. So whenever I find that I have to do a GitHub action or something like that, it's a little bit frightening to me, right? I don't like it. For some reason, I cannot force myself to learn it, right? And I know that the bad is on my side. But with agentic AI, it's very liberating because I can now have the AI to fix infrastructure. I can have an AI to do changes to our front end, which I'm also not very good at. So I can kind of unblock myself. And even better, I no longer have to pull in one of my colleagues to help me out with a GitHub action or some React changes or whatever, right? So this is a very, very real win that I can stay in the flow. So there are several benefits to agentic AI in my experience, but I've also seen plenty of challenges. And this slide is to kind of back up what I said before, that being agentic is much, much harder than coding manually. And I have some numbers to support that statement. And these numbers come from actual real research. So the first refers to quality. So if you adopt AI naively, then you will find that you're very likely to suffer more defects and poorer quality. In this particular study here, done on 600 developers roughly, the researchers found that there was an increase with 41% more defects after adopting AI. So that's very, very significant. What's also interesting is the second study. This is actually one of my favorite AI studies. It's really, really well designed. So what the research team did here was that they studied open source projects, lots of them. I think they had more than 1,000 open source projects. And they gave the open source projects access to Cursor, which we of course know is on like an IDE, an agentic platform and whatnot. And what they found was super interesting. They found that velocity, in terms of how fast can you complete a task, went up rapidly with the adoption of AI. In fact, they found that people were capable of completing tasks more than 200% faster. So very, very real speed up. However, what was so interesting was that velocity gain kind of started to disappear quite rapidly too. And after just 2 months, all that initial velocity gain was fully cancelled out and then some. And the project was now worse off than before they were adopting AI. They were becoming slower. And the reason for that was due to a massive, massive increase in code complexity and unhealthy code. And this is something that we see in our own research. So I'm part-time a software researcher too. And I'm going to show you some of that research throughout the talk. But my observation is that AI seems to operate in a self-harm mode. So if you don't safeguard an AI, it's going to write code that the AI itself eventually cannot understand. And once you have started to accumulate code quality problems and code smells, then it's simply a downhill slope from there. So these are some of the key challenges I see. The good news are that these are solvable. And the rest of the talk is going to discuss how to solve these problems so that you can reap the benefits of AI acceleration without sacrificing quality.
And just in addition to the previous slide about the return of investments, it's your experimentation is in a greenfield or brownfield with your team?
It's a mix. So we do some new products that we started to develop now in the agentic era, but we also have the CodeSyn tool itself, which is our main product, and that code base started in 2015. So it's an 11-year-old code base.
Okay, thanks.
All right, so let's start to look at the solution space then. And the first thing I want to talk about is something I call code health. So code health is something I'm going to use as a foundation for the safeguards and as a measurement of good, because I think in the AI era, I hope I can explain to you as we go along, but I really think that we need a way to know if a piece of code is better or worse, and we need to know that objectively, not just by opinions. So code health is a measure that's designed for that. And the way it works is that if you look at the code to the left here, you don't need to look at the details, but if you look at the overall structure, you see it looks really, really messy. It's really hard to guess what that code does. It doesn't express much intent. And consequently, this code will be hard to understand. It will be hard to change. And it will be really, really hard to maintain, because every developer going into this code need to kind of debug it and try to build up a mental model of it. So this is code that would have a low code health score. It's unhealthy code. What we can do is that we can restructure the code. We can refactor it to try to express the intent. So the same code that you see to the left can be expressed like this. I'm going to give you just 5 seconds to look at it. I don't want you to look at the details, but just like the overall pattern. So the code to the right, I would like to claim is healthy code that's very easy to understand. And if you need to change something in, say, how feedback is evaluated, you know exactly where to go in the code. So this is code that supports humans. What about machine? Is healthy code important to an AI or not? To shine a light on that, me and my research team set out to do a study. And what I'm going to show you now is based on peer-reviewed research. You're going to get the link. I also have a simplified white paper that summarizes the findings. But what we wanted to do is to see, is there a way to kind of predict AI performance, to identify parts of the code where the AI is capable of doing a good job versus where it will struggle? And the way we did it was that we studied something that we call break rates. That's what you see on the y-axis here. So how did we do this? Well, we used an open data set that had a very strong unit test suite. So using the unit tests, we could use them as a ground truth. Did AI implement the correct functionality or not? And then we simply let the AI loose to implement various problems. And we studied this on 25,000 files, so large scale study. So the break rates, how many errors did AI introduce, is what we see on the y-axis. On the x-axis, we see the code health scale. And what's so interesting is that in our previous research on human understanding, we found that the cutoff point for healthy code was at 9, right? So that's like the green section. But what we see is for an AI, we need to push code health and code quality even higher. Because the difference between a perfect 10 in code health, code that's perfectly understandable, versus code that's just slightly unhealthy or just below 9, is a 60% increase in defect risk. So that's quite significant. What we also see in another line of research is that implementing the same problem in healthy code versus unhealthy code makes a huge difference in token consumption. In healthy code, you tend to spend maybe 35 to even 50% fewer tokens than in unhealthy code. So this comes with a very real consequence. Now, of course, given this foundation, how do we use this data to make better decisions around AI coding? So the first pattern I want to show you is something I call assess AI readiness. So right now, a lot of companies are in early adoption mode, in pilot mode. So I talk to enterprises all the time that look to do an AI pilot. And the thing is that if you don't know about your code health and your code quality, you're going to run that pilot blindfolded. And it's very likely that you pick code that is unhealthy and the AI is just going to fail you in implementing any features. And your pilot will be deemed as a failure. So a much safer way of doing this is by looking at the code health, the code quality in the system. And you see a visualization here. So this is a visualization of it's a real code base. This is Power Toys from Microsoft. It's an open source project. And each one of these colored bubbles shows a file with source code. And they're categorized according to the 3 different code health categories here. So what I typically recommend is start using AI to automate feature development in healthy code. For unhealthy code, I wouldn't recommend to try to automate any feature development whatsoever. What I would do instead is I would rather schedule this code for refactoring and an uplift so that I can start to accelerate safely.
But just
So
for to move to the green area of healthy code, should we use AI or manual refactoring, you know?
it will be a combination of both. I'm actually going to talk a little bit about it in a couple of minutes.
Okay.
But you can definitely use AI to do the uplift. To me, that's one of the big benefits of AI. So first pattern is about risk. Know and decide where to use AI and how much agency to give the AI. The second pattern, I think, is even more important. This pattern is all about safeguarding generated code. Remember that I said earlier that AI operates in self-harm mode. So if you happen to have code or you do greenfield developments, you start on something new, the first code you write is going to be a perfect 10. It's going to be super healthy. But then as you start to iterate and add more features or things, change things, the code is going to deteriorate in code health unless you safeguard it. So this is really, really key. And this safeguarding can, of course, be done automatically. So what we did with my team is that we implemented these safeguards in an MCP. So we simply took the code health metric, added it to an MCP, and I'm going to give you the link later if you want to test it out. But let me start by showing you what it looks like. So here I am in GitHub Copilot chat, and I'm asking GitHub Copilot to implement something for me, in this case, some payment solution. And the AI, of course, happily complies and gives me some code. And that code looks quite messy. So the MCP server reviews it and says that, hey, this is no good, try again. The AI iterates, and it makes a slight improvement, but it's still not healthy enough. So it gets a third attempt. And this time the AI has managed to self-correct, and it's now delivering code that's perfectly healthy and continues to be AI friendly. And the nice thing with this is that this tool, this MCP server, its feedback is intended for the AI, not necessarily the human. And the AI is really, really good at self-correcting once it knows what's wrong. So just to sum it up, without these safeguards, we would have been left with a really low code health code that would be really hard to understand. With the MCP, we managed to get the AI to self-correct and deliver healthy code for us. And this is interesting because there's a brand new research paper that came out, I think, just 10 days ago. And what I like about this paper is that almost all studies you see on AI productivity, they focus on one-off tasks, very much classroom tasks, right? And a lot of these agentic benchmarks are also classroom tasks. But when it comes to software development, 95% of the costs are after the initial version of the code is written. So that's what we want to optimize for, long-term maintainability. And this line of research here, it's the first time they actually simulated a real software project going for 6 months and looked at, can coding agent not only solve the initial task, but also maintain the code? And what they found was pretty much what we found in our research, that, yeah, AI works really well for the local fixes, but they struggle to maintain and evolve real code bases over time. And there is this really important quote there at the bottom that I really like you to keep in the back of your head, that the consequences of past decisions accumulate. So that's why I think it's so essential with safeguards. So the pattern I suggest is this, that we generate code, and then the MCP is responsible for checking all the AI-generated code. So the agent will kick on the MCP will review it, and let the AI know if it did something wrong. And when that happens, the AI will simply try to get itself into a refactoring loop, try to fix the code based on the feedback, and then we do a new code health review. And if the code is healthy, we have safeguarded the code and can continue to iterate on a feature. So it's very much a continuous process, very much a back and forth between the AI and MCP. So that was the safeguarding pattern. The next pattern refers to the question I just got. How do we do this uplift? And I think that's really important because, to me, legacy code is going to be the main barrier to enterprise-wide AI adoption. Simply because an AI really struggles with legacy, just as we humans do, because legacy code is often poorly structured, the intent is unclear, and it's really, really tricky to iterate on that. At the same time, we want to use AI as much as possible. And that means we need to expand this surface of AI-ready code or AI-friendly code. Now, how can we do that? Well, again, if we have structured data about the quality problems, structured data about the code of problems, and we can present that to the AI, then we do 2 things. First of all, we give the AI an objective measure for what good looks like, right? So the moment the AI knows what good looks like, it has a goal that it can start to plan towards. If we also provide it with the delta, the difference in code quality between where you are now and where you need to be, then the AI can make that plan and start to execute it. And for many, many problems, you can do a fully agentic code health uplift. So I want to show you how that can look. So this is a piece of C++ code. It's like, no, it's like, yeah, it's C++. It's not my code. I can take neither credit nor blame for it. It's open source code. But I did an experiment here. I had a code health of, I think it was around 8. And I simply asked GitHub Copilot to uplift it. And I have this MCP server in the loop. So let's see what that looks like. So we see here that it managed to do the uplift from 8.3 all the way to a perfect 10. And it kind of also lays out the intermediate steps that it did to achieve that. So that's what I really like, that these agentic uplifts, that to be successful, they have to be very iterative, just like a human would do it. And then, of course, I need to have a strong test suite, but that's something I'm going to talk about soon. So by doing this uplift, I can remediate a lot of technical debt. And what I also like is that the AI is very good at summarizing the improvements it has done, and can, of course, automatically run tests, automatically check that my quality gates passed, so that I can merge and deliver with confidence. Now, this is another thing. I wrote about this just the other day, so it's also brand new research. We've been looking a lot at refactoring simply because legacy code is such a big problem. And we were interested in looking at, can an AI safely refactor code on its own? Why do we even need an MCP server? Why do we even need an external metric? So we tested this on Claude Code using the latest Claude Sonnet. And what we found here, by the way, the y-axis now is the number of code health issues that the AI managed to fix, that agent managed to fix. And we see here that when we just drop in on a generic agent, it will be able to fix some of the code health issues. In a best case scenario, maybe 50, 60% of them. But in many cases, it's going to struggle with do the uplift on its own. And it might only fix 20% of the code smells. And there are multiple reasons for this. I cannot tell for sure because I don't know what Claude's training data look like. But my suspicion is that there are very few examples of code that's relatively sound that has been refactored to become even more structurally sound. So the interesting thing here is that the moment we took this experiment, rerun it with one critical difference, we added the code health MCP server to add that feedback loop. And what happened now was this, that we managed to consistently refactor 90 to 100% of the issues. So we got a very, very high fix rate. So this, to me, is the combination that allows us to do an agentic uplift of unhealthy code so that we can start to accelerate from there. Now, I have one more thing I wanted to talk about. I want to talk a little bit about tests as well. And I wanted to start more specifically to talk about code coverage as a behavioral guardrail. So this is my next pattern. And before doing that, I need to make a quick confession, because it happened that I have been wrong. So when I wrote Your Code as a Crime Scene, I made this statement about code coverage that, yeah, it's useful, but it's also frequently misused. And I made this claim that all problems with code coverage starts the moment we make it a KPI and require a minimum threshold. Because I've seen that happen in so many companies, right? You add a tool, and the tool happens to have a default code coverage of 80%, and now everyone tries to game the system to achieve 80%. And for a long time, I haven't been that happy about using code coverage as a KPI. But what I found is that with agentic coding, it becomes absolutely essential. So why is that? Well, the problem I'm trying to solve here is that even if we have a high quality code, even if we have only healthy code, that doesn't guarantee correct behavior. It doesn't guarantee that we've implemented the right thing. And specifically, a very common shortcut for an agent, this has happened to me many, many times, is that I have a strong unit test suite. I make a change. The agent reruns the tests, and a test fails. And the agent is instructed to fix the test, of course. And it fixes it by deleting the test. So now my test suite passes, and I'm under this false impression that everything is okay. So this can very much become a real risk. So we need to kind of safeguard our tests too. And the best way I found to do this is by using code coverage as a behavioral guardrail. And I even went as far to implement in our build pipelines. So this is an example where it looks like this is one of our open source projects. So I see here that each time I open a pull request, I check 2 code coverage gates. I, of course, have a check for new and changed code, where I require a very high threshold. So I want to virtually cover 100% of all code. I think it's really important when it comes to agent. Agents really pushes the bar on what's acceptable. But I also have this first guardrail of overall code coverage. So here I measure the code coverage in the whole code base. And if I notice that that one drops, then it's very, very likely that the agent deleted some tests that it shouldn't have deleted. So I can now catch that immediately in the pull request. And this pattern has saved me on multiple occasions. Now, the final pattern I want to talk to is test automation end-to-end. So what I find fascinating is how AI kind of pushes the boundaries of what good looks like when it comes to engineering principles and discipline. So end-to-end tests, test automation has always been important in allowing us to ship fast and predictably. But with AI, it becomes essential. Because if we stick to just, say, unit tests, then what's going to happen is that we're going to shift the bottleneck with AI. So writing code will be very quick. But if we still have to rely on humans to go in and manually validate and verify, then we're going to create a new bottleneck. It's going to be impossible to keep up. And a lot of that speed that we win and gain with AI, we're going to lose in the manual work that we've done. So to me, that means that automating tests and checks end-to-end is more important than ever. And what we did when we, for example, you can check this out because our MCP server is open source. What we did with that one was that we have a very strong unit test coverage. I think we're at 98, 99%. But we also invested a lot in building these end-to-end tests. And to really check it, what we do is in each test, we actually create a new Git repository. We generate some code with some known code half issues, and then we kind of run the real MCP on it in different scenarios to ensure that it really catches the problem. So we spin up the MCP end-to-end to really guarantee that it works. And this has allowed us to ship with very high confidence. So sometimes we have a customer that reports a potential problem, and within an hour, we have a new release out that solves that problem. So it's very liberating to have this level of test automation. And that has brought me to the summary here. So I'm going to give you a couple of references, and then I look forward to a conversation and also answer any potential questions you might have. But to me, if I take a step back, being fully agentic doesn't really change how programming looks. It's not really about AI to me. It's about engineering discipline. Because to reap the speed that AI delivers, our code has to be good. We need both good design and automated safeguards because there's no way we as humans can keep up with the AI. And short feedback loops, like quick and well-designed tests, is really, really the key enabler for progress. And if you want to read more on this, I have the link to the research that I talked about with AI-friendly code. And then I also have a deeper dive into the inner developer loop for AI coding, where I talk a little bit about this safeguarding pattern and why it's important. And of course, if you would like to check out your Code as a Crime Scene, I would be super happy to hear that. And finally, what we have decided to do is to launch the CodeAlpha MCP server as a standalone product that you can download. And it's going to be available, I think, already on Friday or on Monday. So if you're interested, feel free to sign up on this link, and you can get a version that you can test for free for 1 month. So you can test out the safeguarding and agentic uplift. And as always, I'm super happy for any feedback on this. I think it's an important contribution to AI. So I would be delighted to hear from you. And I'm going to post the link as well in the chat, together with the PDF of the slide deck, in case you want to look back at some information. But with that said, I want to take the opportunity already now and say thanks a lot for having me at this meetup, and thanks a lot for listening to me. And I'm very much looking forward to discussing this. Thank you.
Thank you so much, Adam. We have some question. I see that what you describe about the code coverage is a Godot law. About the measure cease to be a good measure when it become a target. And we have a good question from Garrick. I think I unmute you. Maybe you can ask a question directly.
Oh, sure.
Yeah.
Nothing further than basically what's in there. My interest in terms of what little work I've done with agentic coding and what I've heard from others is I know a number of people that have really leaned into the notion of, yes, test coverage is great, and you really need mutation testing to make sure that the agent isn't really trying to pull nasty tricks on you with regard to neutering tests, to put it politely. Is that something that you've been looking at as well?
Oh yes, definitely, definitely. So it happens that my research colleague, his specialty is mutation testing. He's a big fan of that. So we also use that in our research. So when we did this, when we studied AI friendliness, we also used mutation tests to ensure that the tests were good enough so that we can use them as a reliable ground truth. So it's a very good point. Thanks for it.
Yeah, it's just kind of funny. I do I'm a technical coach, and one of my favorite exercises, of course, is taking people through Gilded Rose, and then demonstrating that the single test that creates an item called foo and asserts that his name gives you something like under Java, it's like 41% coverage. It's kind of my scared straight pitch. Thanks.
And
Thanks.
maybe you can explain how we can set up the mutation testing in your team. Yeah. Adam.
Yeah. So mutation testing, I mean, there are lots and lots of frameworks for it. So you need to find a framework for your particular programming language, right? But then from there, a lot of it is automated. So what mutation testing does is basically it's testing the tests, not the code. So it simply goes into the code and start to replace certain symbols. So in Java, say, it would replace it can do things like invert an if statement, change on logical and to an or and stuff like that, right? And runs the test. If test breaks, a good test. If the test passes, it's simply meant you have a gap.
Yeah, it's in Java we have PyTest. But my point is how in your maybe the when you figure out the code health metric, do you use the mutation testing in order to do that?
Ah,
Or
no,
because
we don't.
okay,
We don't. So code health is it's like a statically calculated metric, and I can tell you a little bit about the background. So when I started CodeSyn, I never intended to do a code quality metric because I thought there are so many of those already. You have cyclomatic complexity and all this strange stuff. So I thought I can just use that. But what I quickly found out was that these metrics are not particularly good. So if you take something like cyclomatic complexity and then you start to control for number of lines of code, cyclomatic complexity adds no further predictive value. So it's a really poor metric. So that's where I started to look at different ways of doing that. And what I learned is that there's not a single metric that can capture a multifaceted concept like code quality. So what we did instead was that we started with the assumption that all code is good. And then we try to prove the opposite. And we do this by checking up to 25 different factors of the code. So we might look for things like cohesion, are there too many responsibilities? We look for complexity and how the code is written. Like, do you have lots of deep nesting? Do you have lots of duplicated logic? And so on, 25 factors. And then the secret sauce, and these are very open. These are not secret, what we use there. The secret sauce is how do we weight these findings together to classify code as green, yellow, and red, if that makes sense.
yeah, it's on your website, the detail of the code health metric. Yeah.
Yes, and I'm going to try to pull up the documentation for it. Let's see here if I can. Here we go. I have it. So I'm going to paste it here. So you see a list of all these things. It's here we go.
Okay,
code.
I don't
No?
see other question. I have a question about more on the organizational model on your team because you have a pragmatic experience with AI. What is your advice to use AI in a team and your advice for junior that join the team? Maybe you can share with us your experience on that.
Oh, yeah. So for juniors, I would say I'm probably the wrong person to ask. So everyone on my team is fairly experienced. So we talk, many years of development. So we had a fairly easy time to adopt it. But what I think is important, and this is something I see at other companies too, the ones that succeed with AI, what they do right is that they focus not on AI, but they focus on the engineering discipline around it. So that means focusing a lot on build pipelines, rapid build pipelines, strong test suits, rapid deployment, continuous deployment. So I think once you have that engineering maturity in place, then you're very ready to start to adopt AI. So that would be my recommendation, to start with like delivery pipeline, make that really strong, and then go with AI.
And in the culture of your team, do you have some rituals on or sharing instance like learning hours or something like that in order to grow the experience, the learning of the team?
No, we don't do it super structurally. I mean, I have an engineering manager. He runs most of that. I know that he does learning hours every now and then, but we are not super formal about it. And I think it's simply because we are a very small team. So
Okay.
we get to talk to each other all the day, and we work really, really closely. So when someone figures out that, hey, this really, really works, then we need to do that. And we were also in the fortunate position that we happened to build a code quality tool, right? A code analysis tool. And we have been using that we have been using codes in our codes in itself since the very beginning. So our code base was in a very healthy space, meaning that we could start to adopt AI, even if it was a 10-year-old closure code base. But what we noticed now, what we noticed earlier, was that we have a lot of checks and tests that run in our pull requests, and these could take like 20 minutes, and that was perfectly acceptable when all code was written manually. But now 20 minutes, it's an eternity. So we are doing a lot of work now in trying to shorten those feedback cycles. AI tends to kind of expose your weakest link.
Uh, we have some question from your attendees. I can unmute your mic if you want, or just leave your question in the chat. No. Okay. So thank you so much, Adam. It's an interesting sharing because you have implemented the AI on your daily work. So it's an important sharing for the community. Thank you so much. I will share the video on our YouTube channel, and if you have some links, I can add it also on the comment of the video.
Yeah, sounds good. I pasted a PDF with my slide deck.
Yeah.
So feel free to add that. It's a publicly available link, so we perfectly okay to share it.
Okay. Thank you so much, and see you
Thank you so
at
much.
the next meetup for our attendees. Thank you.
Take care. Bye.
Bye.